The lineup here was absolutely perfect. So today's talk is not going to be particularly technical. We've started work on a static analyzer. And so first I'd like to sort of outline the problem that we're dealing with. And the end goal here is basically to start a conversation with all of you. Especially in the back of my mind, I'm thinking exactly kind of the customers like Oliver that we're dealing with SimCorp. But I want to outline what static analysis is and what it can be and what it can potentially do, and get your input on what kinds of extra tooling and what kinds of pain points you have with APL. So as you listen to this talk, I would like you to be thinking, what tools could I have? What questions could I have answered about my code that would make my life easier? From there, we'll talk a little bit about where we've started off, what work we've done a little bit, and then where we want to go from here, and the other potential futures, directions we can take the work that we've started. So static analysis, I'm sure many of you here in the room know what this is, but so as Oliver mentioned, there's compliance concerns, right? So if you need to, you have a large code base and you need to know certain properties of it that give you confidence that it's doing things that you expect it to do. So you have things like security, being able to have artifacts that you can show that you can communicate with people that you're taking security seriously, and it's actually directly related mechanically to your code base. I mean, clearly finding bugs is an issue we all deal with, and just in more specific, like writing code. If you're doing like scripted APL or something. In other languages, we have linters and things like this to help us out, but this doesn't exist in APL. That's another sort of class of bugs kind of things. And then enforcing policy is another issue that's related. So if you have a large team, like 500 developers or something, and you have conventions that you need to put in place in your code base, where dimension you just talked about, you have this whole type system to sort of enforce policy on your code. A static analyzer has the tooling to allow you to enforce policy on a more granular level. And so this sort of cluster of issues that are surrounded about getting information about your code and then acting on that information is all what static analysis is about. And so in your minds, I want you to think, what kind of information do I want from my code, the code base that I have, and what's hard to get at? And even if it sounds like it's wildly impossible, we want to hear like the aspirations that you have for what you want to hear in your code, and then we can work towards getting to a solution that's closer to that and potentially answer those questions. So static analysis, on a high level here, what we have is we have your code base, and then separate from that is a bunch of rules, a bunch of statements you make about your code that you want to be true. We put it through a grinder machine, and then on the outside, it just outputs a list of issues or something. If anybody here is familiar with like SonarQube or some of these tools where you can generate issues and you can go onto like a page and look at all of the generated issues in your code base and tie those back to where they are in the code and address them. And that gives you, this is just a high level, like what the architecture of a static analyzer would look like. Okay, so that sounds great. We can look at code. You could potentially write regular expressions or something to find things in your code and do all of this. But there are quite a bit of challenges, especially in APL. So I mean, right up the top here, the famous refrain is that APL is not statically parsable, right? So academically, you just can't do this. You run immediately into the halting problem. There's going to be things that you do in APL that you have to run the code just to understand what it's doing. But that is one hard constraint that we're dealing with, but there's ways around it. Another issue, if you've ever used any static analyzers in the wild, like Node Audit or some of these, you'll get a flood of issues. Like Node Audit is kind of hated in the JavaScript community because it just outputs literally thousands of issues for like just a standard blank template project because all of the libraries it's pulling in things. So if you get a flood of issues, they're essentially useless because you can't deal with them. False positives is related. right? If you have a list of false positives, we want to be able to avoid spotting a bunch of naive patterns in code that's generic. And so if we get it out to your clients that you want to have the confidence that whenever you have an issue that's flagged, it's worth your time to look at. Otherwise, you're just not going to use the tool. And then another issue is just getting the code base itself. Some of our clients have code that is sort of very dynamically generated. I mean, this is part of the dynamics, but it's sort of split between several different formats of storage if it's just in the workspace, or it's scattered in component files or things like this. So just getting the code in a format that we can look at the entire holistic part of it, and then you can push that to a static analyzer is one problem that we're seeing. There's a lot of dynamic code generation. So you can have pieces of APL and strings that are getting combined in multiple different ways. And the semantics of what that code is doing changes, but we want to be able to analyze it. We want to be able to throw that, have guarantees that it's doing what we want, and have artifacts to prove that it's doing what we want. But then we also have legacy artifacts in a lot of these old code bases that have been around for 20, 30 years. I've seen like old quads that don't exist anymore and things like this. And so we need ways to handle code bases that have some of these warts and interesting features to them, so that we don't just fall over, and we can roll along with what the current code bases are. And then trad funds is a huge bugbear for us because of its dynamic scope, and it introduces all kinds of particular constraints that we might have to put on a code base. You can write very pathological APL, where like if you're in the middle of a function and a particular variable, you don't even know it's like quad inc. You don't know its name class. But no one's really. You can technically write APL where any variable could be an operator, it could be a variable, or it could be a function, and you could potentially write code that handles that. But it's probably not what you want to be doing. So we're having to think, because trad funds allow a lot of these kind of pathological possibilities, we're having to deal with, figure out what those challenges are and how we're going to handle them. Okay. So that's the basic outline of the cluster of issues that we're dealing with and the problems. I hope to hear more from you. What kind of challenges you think make static analysis difficult. I mean, some of the prevailing wisdom is that it's just not going to be particularly useful or helpful, but we want to turn that on its head a little bit. And so the solution that we are taking right now is to incrementally develop this, because my intuition is that in order to make this useful, we're going to have to bake in a lot of knowledge in your individual code bases. Instead of having like a generic public list of a bunch of rules, we want to be able to go in and write things that you want about your code, and we can bake in knowledge that you have about your domain, the problem that you're solving, into this, that allow us to have constraints that can be leveraged that couldn't be done in a generic tool. And so and in the first step to get there, we're just trying to prove that this can be done and give ourselves the confidence to move forward, because it's going to be to write some of this code is going to take a while. And so the initial targets we have are, we want to show, the first one is we want to know that we can actually detect a security issue. So if you have like secrets embedded in your code, so like passwords, API keys, or things like this, they can be sort of dynamically pulled from locations or split around or something. We want to be able to track those and show that we can find something that's security related. Then execute handling, this is a big one, right? Since execute is used everywhere, in 20 maybe we can actually mechanically migrate to something a lot better, but we need to get a handle on the different ways that execute is used, and then figure out a method to verify, or to figure out a method to handle them. And so one of the first cases is just, instead of quad VFI, we're using, a lot of people use execute. So potentially we can find these and in a robust way and handle them. So we have that on as one of our targets. Then some lint issues, those kind of pop out automatically. You'll find all kinds of random non-parse errors and stuff that would generate a parse error if you ran it and things like this. Some of the dynamically generated code, it's part of execute. We also want to be able to handle that. So if you're generating code in your code bases dynamically, we are from the beginning, we're thinking about the problems around that. And then we also want a minimal, we're not focused on how this is going to integrate into larger systems right now. Like we can easily generate issues for SonarQube and things like this. But right now we're just going to try to deal with the technical issues first. So this is the cluster of initial targets that we have. And the overall architecture, I mean, Morten also kind of mentioned a lot of this, but we're integrating with Co-dfns. So the basic structure here is Co-dfns will spit out a highly semantic tree, this AST, this abstract syntax tree. So it'll take your code, push it through Co-dfns, and then spit out this AST, and that's whenever Co-dfns is done. And then from there, the entire static analyzer itself is just a rule database, which is just APL. So it ingests this structure, this data structure here, and then we're trying to design a language around to allow you to read this and make statements, make assertions about this AST, and that will be your rule database. But it's just APL. That's the whole point. So in a way, the entire architecture is extremely flat. So it's essentially just finding a way to allow you to write some APL to run on your code, and then that can generate the downstream issues. And right now, let's see if I should have some examples. Yeah, the look and feel. So right now, this is just using like the Co-dfns style of writing and parsing. But something on the top, like the top line, this would be like a type Z node. So in your tree, you'll have a lot of nodes. So if you have a type Z and a K is -2, so it's a type 2 and a kind -2, or type Z and a kind -2, we know that that's a syntax error. That's just how you would write this in Co-dfns right now. Of course, like if you see this and you just absolutely gag, that's fine. Please let me know. I'd love to hear that. We can all design sort of DSLs around here. Morten has pushed for that. But some of these lines, I mean, your lines, like right now, if you just wrote it, you could write it compactly. Some of the things we can detect global variables that are not localized. And we can detect, assignment to like these last two lines here are, I'm waving my hands. This isn't completely working right now, but this is what it would look like if you're trying to find like an embedded secret or something like this. We'd have to do something more sophisticated. This is just finding an assignment, a direct assignment of a password to a variable or something, but we're gonna have to do a little more than that. But this is kind of what you can envision. You're just writing some kind of APL on the left, and it's finding legitimately semantic issues. And the questions that we have, like I said, there's the DSL. If you want to wrap some of these things, I imagine there's certain patterns that were being used. I think Asher will talk about some of these patterns on traversing trees. Do that tomorrow, I think. And then, but we might want to wrap some of these things around to make it where whenever you see your rules, it just kind of reads directly most closer to English. Or not. I kind of think this is better, but it depends. Then there's also a trade-off that happens here. Right, if you have a rule database that's making assertions about your code, whenever you change your code base, those can they can break. So if you get particularly precise about the things that you want to be true in your code, it makes the rule database more fragile, which means if you make any changes, you're more likely to generate a bunch of spurious issues or things. So one of the questions we have is, what kinds of rules do we want to encourage people to write? What is the shape of those to make sure that they are robust against the long-term development of the code, your application code. And then, do we need helpers for writing, like rule writing itself, or how much do you want? How much collaboration do you want with particular dialogue? Some of us developing the static analyzer, do you want all of this to be in-house? There's a discussion to be had there. So these are this is what it can kind of look like, and some of the questions around what usability of a static analyzer will be. All right. and our future. So right now we're just at the proof of concept stage. We've just started, I think, about 2.5 months ago. And we are still struggling with, so a lot of heavy technical glitches right now, but we're hoping within a few months out to, half a year out or something, we'll have a robust answers to some of these big questions that we have. And then, sort of the progression of where we want to get to is, as Morten said, where we can have we can have this tool in your hands so that you can be getting the developer tools that you need, sort of like if you want linters, if you want tools to be able to make enforce policy in your code. So we want to get to that end, but then we have sort of like, there's certain technical barriers that we need to get past to get to there. And so it's sort of a four-step kind of plan that I have vaguely thought about. I haven't talked about this a lot with Morten yet, but some of the open questions we have before we get there are, I mentioned handling dynamic code is quite challenging. Some strategies that we've come up with are just taking snapshots of production code and being able to output that and then munge it and so that we can analyze it, or having that dynamic code be maintained and working in collaboration to get you to write that code, or like write that code out and get like sort of instead of just a single snapshot of a piece of the system, have a more holistic or a whole view of all the dynamic code that's potentially generated and have that something that you would maintain, and then we can just push that in with all the code that we analyze. And we're trying to consider a bunch of different strategies, but it's going to be a trade-off of how much coverage that you want in this dynamic code versus how much work you think that you need to put into it, and what guarantees you need for to be able to stand up, and if you have like this type 2 audit come in and be able to give real answers that can give you the confidence that you can handle those kind of things. But all of this requires trade-offs. So like the particular issue with not being able to statically parse APL, there are trade-offs like with some of this pathological code. We can say, well, we can flag the places where that code doesn't happen, or where that code looks like it potentially happens in that way, and then make a policy where we can't support bad APL per se. And then by putting enforcing those rules on your code base, it allows us to move forward. But we need to know, are you writing code where you want to be able to be populating your namespace dynamically with a bunch of globals from within trad funds, or do you consider that bad style? Or do you have particularly like handling semi-globals? Do you have particular extra strategies for finding out where your semi-globals are coming from? And if we could leverage those, it might be able to make this tool more powerful and more expressive. Some of those things that would flow into allow you to write rules that have the semantics that you want. But we don't know what this is going to look like. That's one of the challenges. It's a whole UI and a UX kind of issue around writing this tool database. And then this realistic constraints around the parser is one that, what was the one that we put in recently? We discussed that if you have a workspace with a bunch of functions, potentially if you have like a trad fund come in, any variable within that trad fund, you could be executing that trad fund from potentially any entry point. Any other function that you execute could eventually land you executing this function. But if you have different paths disagree on what your variable types are in this trad fund, it can make parsing it's a pathological parsing kind of problem that we'd have to. So we want to say that you can't do that. But are you relying on that kind of feature? It sounds like pathological APL to me, and to Morten, I believe, whenever we talked about this. But we don't really know what kind of code you are writing and what you want to be writing, and what are your conventions whenever you're talking to colleagues. Like what kind of code do you discourage, and what kind of code do you try to encourage, especially around the handling of names and bindings. That would allow us to move forward quite a bit. But those are the main open questions that we have, and we are sort of preemptively coming up with answers so that we can explore some of the code bases that we are looking at right now. And this will allow us to sort of try and get at some of your potential wants. So these are the questions that you can potentially think about. Do you want a code linter? Would that be helpful in your work at all in communicating with your colleagues or writing your own code personally? If you say no, then fine, we don't have to do something like that. But if yes, we can figure out tooling to potentially make that possible. What about tracking variables? So if you want to know the call chain of where your variable, what the value of a variable comes from, or or better yet, you can know, does this variable just come from an internal value, or does this actually have data inside my variable that's coming from the outside, from user input? We can track some of those kind of things. Is that a problem that you're having? Is that something you think about? What kind of security? What are the scariest kind of security issues that you're worried about? And then whenever you have it migrating between versions of Dyalog or off of other APL systems, what are some of the biggest pain points that you have? I know that Dyalog also puts a lot of effort into aiding that, but static analysis could potentially make some of that transformation mechanically and automatically possible. And I just want to know what some of the biggest sticking points are there. But these are just example questions or example things that I would like you to think about and talk to me or Morten or Aaron about. And then controlling of semi-globals, I already mentioned that. And then enforcing conventions or something. If you have a wiki page, or if you have, I don't know, some style guide or something within your company, I would be very interested to look at that and see what kind of code your APL you are trying to write. And thank you very much. That's static analysis in APL.